Hello, howdy. How are y'all doing? Hope you're all having a good day. Welcome to another Hornet Security and Altero Software webinar. This one on how to unlock your storage potential with these powerful built-in Windows Server features. My name is Andy Syrewicze, and as usual on so many of these webinars, I've got a good friend of mine here to kind of be a co-host and a co-speaker today. I've got Didier van Hoye. How's it going, my friend?
Hello, well, I'm doing just fine, and I hope everybody is doing the same.
Yes, doing very well, and it's good to have you here. I mean, this is I always tell people like, hey, if you have a question for me, a storage question for me that I don't know the answer to, go talk to Didier. You've always been my go-to resource for storage stuff. So it's good to have you here and share your knowledge on, the kind of the storage features inside of the Windows Server stack. And
You're welcome.
we got a ton of great content here today. So I think what we're going to do is we're going to dive right in because we have a lot to get through. So let's start with just kind of a quick rundown of what we're here to talk about today. So first, we're going to do some introductions, myself, Didier, and then Hornet Security, the sponsor of today's webinar, and then we're going to get into kind of our key content areas. Now we're going to talk about Storage Spaces Direct / Azure Stack HCI, and you'll understand the association there as we get through that section. We're going to talk about persistent memory, SMB and quick, ReFS, and then finally we're going to do some wrap up and Q&A at the end. Now, quick thing about the Q&A, feel free to put your questions into the GoToWebinar questions form as we step through the content today. If we have an opportunity to kind of organically stop and address any of the questions that come through, we certainly will do that. Otherwise, we always try to cover as many of the questions at the end of the webinar as we possibly can. We're not always successful. If there is a situation in which you asked a question that you did not get an answer to, we always do some sort of follow-up content, whether it's a video or a blog post that contains, basically a list of those questions and their associated answers. That way, if you ask a question, you get an answer in some way, shape, or form. So, like I said, get those questions into the GoToWebinar questions panel as you think of them, and we will address them at some point. So with that, let's do some introductions. Again, my name is Andy Syrewicze. I'm a technical evangelist for Hornet Security. You've probably seen me associated with Altero Software. So Altero Software, we are now part of the Hornet Security Group. So that's why you're seeing both of the logos up there. I'm a Microsoft MVP in the Cloud and Data Center Management competency, as well as a VMware vExpert. So I've spent a lot of time in the virtualization world. I'm quite active out on Twitter. So if you want to hit me up there, you have any follow-up questions, or you just want to say, hey, go ahead and reach me at @asyrewicze. Apologies, you'll have to spell the last name, but it is what it is. With that, I'm going to pass it over to Didier so he can introduce himself.
So my name is Didier van Hoye, better known as working hard in IT on the internet. Work mainly as a Microsoft infrastructure architect, and that is both in the data center, hybrid, and cloud environments. And just like Andy, I'm also a Microsoft MVP.
Sounds good. Appreciate it. And then a quick word about today's sponsor. Again, the company I work for, Hornet Security. So we are, the most comprehensive cloud security service for Microsoft 365, including things like spam filtration, advanced email security, encryption, continuity, archiving, some compliance features like signatures and disclaimers, as well as backup and recovery. We also can provide a lot of those same features for, things like Google Apps or on-premises Exchange servers, or maybe you're running some sort of open source mail server. We can provide the same types of services for those types of installations. On top of that, we also do fully secure hosted mailboxes, web security, and of course backup and recovery for VMware and Hyper-V based workloads. A little bit more about the company. So Hornet Security is really a global organization. We span 3 continents, 17 offices, 9 data centers, fairly large organization. From a little bit of a history perspective, and Hornet Security really got its start back in the 2007, 2008 timeframe. Started with some mail archiving and mail encryption, and then more recently has really started getting into the M365 world, has been making a lot of strategic acquisitions to round out that product suite. So, Hornet Security focuses on the security and the data protection. That way you can focus on what it is you do. And then with that, let's start getting into our content for the day. And the first thing I always like to do with these is start with a little bit of a poll. And we do this so we can kind of get an idea of where the audience is at and we can kind of tailor the conversation a little bit one way or the other. So the first poll that I'm going to launch here is, what storage technologies are you using in your environments today? So here you can select all that apply. We've got traditional file servers, your traditional iSCSI fiber channel SANs, storage spaces, Azure Stack HCI, persistent memory, ReFS. Didier, I'm guessing this is probably going to play out like this morning session did. Everybody's going to select traditional file server, right? I'd be surprised if there was somebody who didn't.
Still very popular, and some have succeeded of getting rid of it, but it's so useful still, and yeah,
right.
it's gonna be with us for a while.
Yes, absolutely. This is one of those workloads that, it's like you said, the convenience factor. Plus, users are just used to it, right? So definitely, I don't see that one going away anytime soon. I suspect we're going to see a lot of people say they're still using iSCSI and fiber channel SANs with a smattering of S2D and Azure Stack HCI. So that's been running for about a minute. I'm going to go ahead and close that and share the results with you all. So just like we suspected, we got 91% that say traditional file server is still in use. No surprise there. Half of respondents are still using iSCSI and fiber channel SAN, which, yeah, that's not really a surprise there. I think this lines up. I'd have to go look at this morning session. This almost looks identical, if I remember correctly. Because this morning,
I think we had a little bit more iSCSI fiber versus storage spaces this morning, but it's not a huge difference.
Yeah, it's very similar. And remember, we had 0% for persistent memory in this morning session as well.
Consistent.
Yes, indeed. So, all right, appreciate the feedback there, everyone. Much appreciated. And let's dive into our content. So, Windows and storage. What is there to tell? Too much for a single webinar, it turns out. Didier and I we sat down and started planning out what this webinar was going to look at, and we're like, you know what? There's way too much to cover in one single webinar. We started talking about the fact that there's so many IT pros out there that I don't know if it's a rumor or if it's just the circles I'm in, but there's like this perception that Microsoft has not innovated in the storage arena, and that's just not true in any way, shape, or form. So when we look at the content that we're talking about in the webinar today, we're looking at this from a very 10,000 foot view, right? Because any one of these topics that we're talking about today could necessitate its own webinar. So what we're going to do with our webinar today is we're going to talk about what each of these features are, kind of where they fit, why you would use it, and at the end of the webinar, I have a pretty, I don't know, there's like 12 links on there if I remember correctly. Basically a resource slide for additional reading, places where you can go to learn more about these topics that we're talking about today. So with that, let's talk about Storage Spaces Direct and Azure Stack HCI. And like I said, after we get through this section, you'll kind of understand why there's an association between these two. But let's start with Storage Spaces Direct, or the acronym you'll hear thrown around is S2D, and that's usually what I call it too. So this is, again, designed to be a crash course, very 10,000 foot view. So let's first talk about what it is. What is Storage Spaces Direct? And essentially, Storage Spaces Direct is software-defined storage using commodity hardware. So basically, you're going to take, I don't want to say cheap, but cheap and commodity, those two words tend to go hand in hand in our industry, right? But basically, you can take Windows Server and turn it into a very high performance, capable and usable storage solution using Storage Spaces Direct. And you've got two different deployment options, which you're going to see on the next screen. But one of the big advantages to Storage Spaces Direct is you have the ability to do compute and storage inside the same chassis if you want. So you'll hear this, this term thrown around in the industry called hyperconverged. You can do hyperconverged deployments with Storage Spaces Direct, and there's a lot of benefits to that. From an availability perspective, S2D is currently available in Server 2016 and Server 2019. And this is one of those rare features in the Microsoft Server stack that is only available in the Datacenter SKU. So if you have Windows Server Standard, you don't have access to it. So if you're interested in it, you can certainly always go out and download the Windows Server trial, try it out that way. but to use it in production, you're going to have the data center licensing SKU. From an architecture perspective, on the left-hand side of the screen here, you can see at the very bottom, the base layer, we've got the raw disks that are associated in each chassis. You've got the software storage bus, and then on top of that, you have your cluster of servers. Now you can go from 2 nodes, I think, what is the maximum, Didier? I think it's 16
64.
nodes is the maximum, yeah. What's that, 64? 64, whoa, that's way higher than I seem to remember.
63, but everybody was asking why not 64, so they made it 64.
See, I don't run into clusters quite that large, but yes, very good. So on top of that, you layer storage spaces on top of that cluster, and then of course, you know, if you're familiar with failover clustering, the cluster shared volumes, and then S2D defaults to using ReFS, which Didier is going to talk about in a little bit. From there, we share out that information using SMB3, and then you host your virtual machines or whatever workload you're going with from there. Now, going towards the deployment methodology. Like I mentioned earlier, you've got 2 different options here. You've got what's called the converged option. That's what you see on the screen here. And you'll also hear this other term thrown around, disaggregated. That's another term of describing this deployment mechanism, which you can always best think of this as how we've been doing storage in IT for the last 10 to 15 years, right? You'll have your compute nodes, and then either through some form of storage fabric, either fiber channel or iSCSI, you're connecting across that fabric to your storage. Traditionally, some sort of SAN, like an EMC or an EqualLogic, anywhere from 2 U's in your rack to an entire rack, right? That's traditionally how we've done things in the data center with virtualization and storage. And that's what the converged option is here. Basically, you would use storage spaces direct as the storage piece of this, and then you would have a Hyper-V cluster that connects through a fabric and uses that storage spaces direct storage for its workload. And then you have the hyper-converged option, which I think is, this is what people tend to think of more when they're talking about S2D, and that you've got storage and compute within the same chassis. Excuse me. So from here, like I said, you've got storage and compute in the same chassis. You've got storage spaces direct layered on top of those. And you typically have some sort of, you know, very fast network connection for the east-west traffic between the nodes, and you serve up those virtual machines on the same nodes that are hosting the storage. Now, let's talk about some quick pros and cons here before I dive into my lab environment. So some pros of S2D. You know, you've got basically it's a native enterprise storage solution for Windows Server by Windows Server, right? It's all contained in the Microsoft stack. It's designed to work with Microsoft products. That's just a fantastic a pro in my view. You also have multiple deployment options, which we talked about already, and it's already included in your Windows Server data center licensing. Now, that said, I think most people who are going to be looking at this feature are probably already licensed for Windows Server Data Center, but if you're not, you could probably scooch that line item over into the cons column because you got to go out and buy that data center licensing. But like I said, I think most people who are going to be looking at this feature probably are already licensed for data center. And then you got that ability to use commodity hardware. I'm going to explain kind of the hardware that I've got in my lab a little bit in a slide or two, but basically I'm just using a Supermicro motherboard with basically a hodgepodge of different components that I've grabbed here or there. On the cons side of the column, we've got, you know, a learning curve. Learning curve can be a little high, you know, especially if you're coming from the VMware space, you've never done anything with Microsoft clustering. There's a lot to learn. You have to figure out how Microsoft clustering works. You have to learn, you know, what's the best way to connect your storage to your, you know, your hosts. What's the best way to interconnect the networking? There's a lot to wrap your hands around. There's a lot of research to be done, and a lot of learning to be done there as well. The second line item is specific to storage spaces direct itself. I mean, if you look at tools like Hyper-V Manager or Failover Cluster Manager, they've been around forever and ever and ever, and they are highly mature and very capable management tools. Historically, with storage spaces direct, you've only been able to manage it using PowerShell. Now, we now have Windows Admin Center, which has a lot of S2D related capabilities in it. So we now have a GUI management tool for Storage Spaces Direct. And while it's good, it's not probably up to the same level as what you're used to with, like an EMC control plane or something like that. It's not the same level that you're probably used to working with those third-party storage providers. And then finally, there's some struggles with 2-node deployments, which could probably be said of any 2-node clustering solution, right? This especially applies in the hyper-converged deployment methodology, and that you've got a 2-node hyper-converged deployment with storage and compute on the same nodes. When one of those nodes goes down for patching, which you're going to have to do at some point, and it comes back up, the cluster, as it were, says that, whoa, hey, some of my disks just disappeared, right? Now it has to go through a rebuild process because there's only 2 nodes in that cluster. It all works. It all does a really good job. It's just something is used the administrator needs to be aware of. So what about Azure Stack HCI? Where does Azure Stack HCI come in here? What Azure Stack HCI, and I'm going to use a Microsoft term here that those of us in the MVP program kind of joke about sometimes, is that Microsoft took all of their learnings, right? You'll hear Microsoft use that term quite frequently. They took all of their learnings and they basically took all their software-defined capabilities and packaged them all up into a nice, clean box. And they had third-party storage and server vendors certify solutions that run with Azure Stack HCI and all of these software-defined data center offerings. Basically, it's all packaged up, and now they're basically branding it as Azure Stack HCI. Now we have Azure, we have Azure Stack, now we have Azure Stack HCI. It's not confusing at all, right? But basically, this chart on the right-hand side of the screen kind of explains it. This is actually from docs.microsoft.com. Basically, Azure Stack HCI is designed to run virtualized apps on premises. And it's natively very tightly integrated with Microsoft Azure. So under the hood, Azure Stack HCI is just Storage Spaces Direct and a lot of the high-level network virtualization tools that are built into Windows Server with a lot of Azure integrations built in. Now, if you need some of those Azure capabilities inside your data center, you would go with Azure Stack, which is the middle column. Or, of course, if you need public cloud services, then you go with the publicly available Microsoft Azure. Now, one other note I wanted to point out while I was actually, working on populating this slide is that Azure Stack HCI 20H2 only supports the hyper-converged deployment method. You can't do the converged option, the disaggregated option, not supported. That said, the official 2019 version of Azure Stack HCI does support both. So just something to be aware of. So from there, what I want to do is I want to jump into my lab environment really quick. And let's do this. You should see my lab environment, Didier.
Yep, we see it.
Perfect. So I'm going to minimize that for a second, and we're going to hop over to Windows Admin Center. So again, Windows Admin Center being the new Microsoft management tool on the block, right? And it's really designed very well for managing S2D deployments. So you can see here on the screen, I'm logged into the Storage Spaces Direct cluster object in Windows Admin Center. I've got a really nice overview here of how many nodes are in my cluster, how many drives total. We got 12 drives. Are all my volumes happy? How much memory am I using? How much storage is used? And what does the cluster performance look like? As you can see here, I'm not doing a ton. 32 IOPS currently. So right now that cluster is just kind of twiddling its thumbs. If you think back to the Storage Spaces Direct, the architecture, we had the physical drives at the base level, right? And if I go to this drives view and go look at my inventory, if you think back to your third-party SAN vendors, you're very used to seeing this kind of this view of all the physical disks inside the SAN chassis, right? And that's kind of what this view is here. If I sort this by server, you can see that in each node, so this is S2D1, I've got 4 spinning disks and 2 NVMe devices in each node. So the spinning disks are used for capacity storage, whereas the NVMe devices are used for cache, read-write cache. So what's nice about the S2D deployment wizard is that it's smart enough to say that, oh, hey, you've got 2 NVMe devices and 4 spinning disks. It just automatically configures the NVMe devices to be used as cache, which is super helpful. The other thing that's really useful in this particular UI is if I go back to the summary drives view and scroll down to the bottom, I can actually see that cache to spinning disk ratio in this read cache and this write cache section. So here I can see that 100% hit rate for read cache. A higher number here is better, which basically means 100% of my reads are currently happening from cache, which is amazing, right? And then on the write cache, basically, if this write cache started populating and it was something other than 0%, that means that the writing operation from the cache to the spinning disk is starting to fall behind a little bit. But again, in this environment, I don't have a ton of writes happening, so that's sitting at 0% currently, which this is fantastic. That's right where you want it to be. Now, that said, we kind of talked about how the storage piece is connected. The physical disks are connected. What do the volumes look like? So basically, I imported all of those disks into the storage spaces direct pool, and then I started carving off volumes, just like you would on a SAN, right? So if I go to my volume inventory, you can see I have 4 different volumes carved off with varying levels of resiliency configured. The other thing that's really worth mentioning here is the file system type. So you can see that cluster shared volumes is in play along with the ReFS file system. So in Storage Spaces Direct, any volume you create here will get mounted to each node in the cluster under C cluster storage, just like any other cluster shared volumes would in a Microsoft failover cluster. From a networking perspective, what I did here is I just connected to one of my 2 Storage Spaces Direct nodes and just ran a getnet adapter to basically print out a list of the adapters. You can see I've got a quad port NIC, 4 1 gig interfaces, 3 of which are used for VM traffic, 1 of which is used for management. If it was a true production situation, I would have 2 for management, but I like to live dangerously, I guess. And then I've got an oldie but a goodie, a ConnectX-3 Mellanox adapter to do the heavy lifting as the east-west storage traffic at 40 gigs. One thing to note there, for this particular card, you don't have to go buy a 10 gig switch. These are actually direct connected between the 2 nodes, and it does work and it is supported. So that's how the storage is laid out. And again, this is really just a high level overview of kind of what S2D looks like, how it's architected. The thing that always comes into play next is like, okay, that's great. I can run workloads on here. So if I go to like my virtual machine view, you can see, hey, I'm running currently 6 virtual machines. I think it is, if I remember correctly here, when the list populates. And 6, yes, 6 virtual machines, currently 3 on each node. The question always comes up like, hey, can I protect these? I mean, if it's just storage spaces and Hyper-V, I should be able to protect it with my backup application like I would, a standalone Hyper-V box, right? Well, you can. So I have also got Altera VM backup running inside of this environment. And if I go to the host view here, you can see that I actually have both of the S2D nodes in the host list here. And you can see that they're both associated with this S2D cluster here, and the little gray box that's next to the names. Now, if I go to the backups view, you can see that I've got all 6 of those virtual machines are currently configured for backups. The backup VM, of course, I haven't taken a backup of that. But if I want to take a backup, I just select my virtual machine and I say backup. And I can go to the dashboard and we'll be able to see that, hey, that virtual machine backup is starting here in just a second. So that should pop up and populate in this left-hand list here in just a second. Yep, there it goes. So as you can see, we can protect, virtual machines running on S2D just like we can on a traditional Hyper-V cluster. So with that, Didier, I know you're probably itching to get at the persistent memory stuff. So I think we're going to pass things over to you, and you've got some cool stuff to show us in the realm of persistent memory. Let's see. I'm going to pass over presenter to you. There you are, sir.
Yes. And then you can see my screen now, normally.
Yep, there we go. Looks good.
So persistent memory, the cool stuff, right? So what can we do with that, and what is it? Well, it's basically a solid state, high performance, byte addressable memory device that resides on the memory bus. So what does that even mean? Basically, you get persistent storage at the speed of memory, or at least close to the speed and latency of memory. You can address these both via a file system, as you would with NTFS, REFS, block access that's called, or directly with direct access, and then the speed is even better. Now, persistent memory also is known under other names. There's NVDIMM, so non-volatile DIMMs, and there's multiple types of those. Then there's storage class memory, and even more in the future, some people are speaking about memory class storage. So don't worry too much about the naming. Some vendors will compete with each other and call each other's names because the one is better than the other, but in the end, they're all trying to do the same thing. And Microsoft recognizes this, and it's kind of fun. If you look under the hood, you will find the PMEM sys driver, the storage class memory bus driver, and the NVDIMM sys driver under the hood. And so they've got all their bases covered. They're not taking any sides in naming this technology. So that's kind of cool to see. So, but why would you use it? Well, if you look at price versus performance and latency, then at the high end, you will find the cache for your CPU and the memory that you have in your servers. Then on the storage side, you have the HDDs, SSDs, NVMEs, and prices go up as performance improves and latency is lower. But there is a bit of a gap between memory and NVMEs. And that gap is where PMEM can fill in the blanks, so to speak. So this is their opportunity. And to do this, they need to make something that is very, very fast, faster than NVMe, maybe not as fast as memory, but close. And at a price point that it becomes affordable if you want to do it at a certain capacity, because let's face it, 16 gigabit DIMMs aren't going to cut it, right? So this is where they are fighting their battle. Now, there's for NVDIMMs, for example, you need a compatible BIOS, and you need to enable PMEM in the BIOS, but that's not the case for all persistent memory. So this is just an example. Once you've done that, persistent memory devices will show up in your system, and if you query those, you can see them in PowerShell. You can grab the unused regions and use those to create a new persistent memory disk. And once you've done that, they will show up. So we have 6 devices, and we have 6 disks. Now, if you want to create bigger disks, the trick is you can interleave them, right? So what you can do is say, hey, pull them together. So this is per CPU. So if you then query the unused regions, you will see that they are tied to multiple devices. And if you create a disk then with new PMEM disk, you will get 2 interleaved persistent memory disks, giving you greater capacity. The big thing to remember here, this does not offer you any redundancy. So if one of those devices here fails, let's say number 3 fails and is in the first memory disk, persistent memory disk, then you have data loss. So you'll need to deal with that on another level. Now, how can you consume that? Well, you can use it on the host itself, which is quite easy to do. You can have it used by SQL Server, for example, in direct access mode, which supports that. So that's cool, but you can also use it as storage for virtual machines with Hyper-V, or you can use it in storage spaces direct. So how do you do that? Well, in Hyper-V, you have this new disk type, VHD PMEM, which is the virtual disk for persistent memory, and you have to create those on an NTFS DAX volume. That's the only way you can do it. It needs to be generation 2 virtual machine, which is kind of not surprising, right? Generations 1 are a bit behind us by now. And there's a couple of limitations at the moment, but that's what you can do at the moment. On the host itself, you have this new controller for Hyper-V, the virtual machine PMEM controller. You just add one to your virtual machine, then you take your VHD PMEM and assign it to that virtual machine via that controller, and it shows up in your virtual machine. You can just query it, and if you say, hey, the bus type is storage class memory, you will see that Hyper-V, the virtual machine, knows persistent memory, and you can then grab it and configure it, partition it, format it with NTFS as a DAX volume or as AreaFS even if you want to. So that's how you use it with Hyper-V. Now, this is real life data from my labs with NTFS in block mode, right? So the slower mode. It's optimized, 100% read, 100% sequential, 4K I/O with 24 workers, 1.5 million IOPS, but look at the latency, 0.016 if we round up. So that's pretty impressive. And then if we say, okay, let's make it less optimal, we'll double the I/O and we'll use 24 workers, but we'll add 30% writes and 30% random I/O. And look at this, it's still well over 1.4 million, and the latency is 0.016 if we round down. So it doesn't even make a dent. And even if you change your tooling, let's say we use disk SPD, you can see that the numbers remain impressive. So we went up to 1.7 million here with a latency of 0.046. So this is just amazing to look at. And once you've seen it, you're spoiled for the rest of your life. And I'm going to be very honest. I unfortunately had to give it back. Couldn't keep it.
You know, I'm going to say you ruined the 4 NVMe devices in my lab for me. They just don't cut it anymore.
Yeah. Now, you can also use it, and this is probably the most common way to use it, as storage in S2D or in Azure Stack HCI. You can use it either as a capacity device, like another disk. You can build your entire cluster out of storage class memory if you have let's say, the deep pockets to do that. But normally you'll combine them with NVMEs or SSDs. You shouldn't combine them with HDDs because the performance metrics are so far apart, it doesn't make sense. And again, you can also use it as a caching device. This makes a lot of sense if you have NVMEs or SSDs under the hood. But of course, with HDDs, again, the difference is so big, don't even bother. Now, the good thing about this story is that it is S2D here that will give you the redundancy. Remember, the interleaved disks persistent memory has no redundancy by itself. Well, the redundancy here comes from S2D. So that's the good news there. So that's about the PMEM. I hope you can find some and play with it in the lab. Now let's go to some other improvements, SMB and Quick. What have we seen? SMB improvements in Windows Server 2022 is we now have SMB compression, and we'll talk about that shortly. We have better encryption, and that's not just nice for security, but they also have better encryption controls for the internal cluster. So that means that you will have separate control over signing and encrypting the traffic between CSV and the storage bus layer. And it will work a lot better with SMB Direct. It will give you performance there. So that's the good news. And last but not least, they've introduced SMB over Quick, which is basically really quick to host SMB over the internet, over UDP and TLS 1.3. So that means that you don't need a VPN anymore. You can just access your file share on the internet securely, transparently, as if you were in the office, which is kind of cool. And we'll look at that as well. So compression, pretty straightforward, but it's implemented now in the file share, which means that an administrator can set it to be required. A user can request it, or even an application can request it. So that this takes away the manual process of having to compress files and copy them over the wire when you might not have enough bandwidth. And if you don't want to store them compressed, you have to deflate them again. So this is all taken care of now automatically for you. Of course, this will consume some CPU cycles, but in the beginning, Microsoft said, we're going to run some tests, and if we think it's worthwhile, we'll do compression. Otherwise, we won't. But I think they are very, let's say, happy with the results, because now it's the default, and everything will be compressed out of the box at GA. It's very efficient on networks like 1 gig networks or Wi-Fi networks. It's not immediately needed on a 100 gig network because it's normally you have the bandwidth and the room there to do it. But still, if you want it, it's there. It has a couple of very nice characteristics, and it's good to see it supports SMB signing and SMB encryption. It works with SMB over Quick. It works with SMB multi-channel, so you don't lose much of your other SMB capabilities, or none at all, except for RDMA. But that's for the moment, because on their blog they mentioned they are working on this, so that's coming. So that's SMB compression. Now for Quick, so that begs the question, what is Quick? Well, it's a standard that aims to replace TCP/IP for internet-oriented data transfer. And it uses UDP instead of TCP. So it really wants to keep all the good things about TCP, the reliability, the fact that it's broadly applicable, but it wants to enhance it. And to enhance it, they required TLS 1.3, which Windows Server 2022 now supports. You take a certificate, you assign that to your file share, and well, Bob's your uncle. You can start using it with SMB over Quick. Microsoft created their own open source version of Quick that's called SMQuick, and that's what is under the hood, and they are continuously improving on that one. Now, why would you want to do this? Well, there's two use cases for this. One is focused on the user. So being able to do file sharing over UDP and 443 instead of TCP 445 is a practicality thing. I mean, for one, opening SMB shares over the internet doesn't seem like a very secure idea. But even if you can secure it, like they do in Azure, and you want to connect to it, most firewalls and most ISPs will block this. So it's not usable that way. So that takes care of that problem. The network changes you can have with a Wi-Fi connection, for example, or your phone, if you lose the connection, you have to reestablish the connection. With Quick, you don't. Just sending it a packet because they have numbers, unique numbers that identify them, is more than enough. So they have more stable, easy network changeovers. That's nice. And of course, the transparent user experience, if a user wants to access a file share, for example, and they don't have to use a VPN for that, or you can go to Azure and access your file share without your ISP making your life hard. Hey, that's a win. And on the other hand, there's the needs from the providers, right? The cloud hosters, the data center boys. You can reduce your TLS overhead. You can have the overhead associated with TCP/IP reduced. There's no head of line blocking involved here. And maybe also very important, it's in the user space, right? It's easy for development and adaptation. You can create an application that leverages Quick. You don't have to wait for your operating system kernel to implement Quick. So that makes things quite interesting in speed of adoption. So how does it work for SMB over Quick? Well, I've drawn a little figure. So we've got a file share set up. You can talk to the domain controller. You have a certificate that you tie to your file share. And then you have a client somewhere on the internet or inside of the company that wants to access that file share. So you will look up your host name in DNS, you will go there, and then the negotiation starts, right? It will first try TCP or RDMA, and if that works, you're golden. But for some reason, it doesn't work. A little bit after TCP/IP, it will try Quick, and if it's set up and it finds, hey, I have Quick enabled, I have my firewall configured to allow UDP over 443, you can connect to your file share over the internet. Now, by default, it will work out of the box with NTLM v2, but it's NTLM and it's 2021. If you are going to deploy a new service for your company, you might not want to introduce new dependencies on NTLM. So they've got you covered there with the Kerberos Distribution Center proxy service that you can leverage to have Kerberos over the internet, which is quite cool. And basically, what is it? You have a domain joined server. If you look at any server now today, you will find a service. It's just not enabled, it's not running because you have to configure it. But once you've configured it, it will handle the Kerberos messages for you for the authentication, the ticket granting service, and for password changes, all securely in an encrypted tunnel. And that's basically what this proxy service does. And we have a demo of this for you. So let's go there. Let me just get rid of, yep, that's one server, and that is the other one, the client. So we have a server set up, and if you look at the server, you will see that we have a number of file shares here. These file shares have been configured for SMB over Quick. You will also see that we have the KDC proxy service running, and over here we can also take a look at the KDC proxy log, and we'll look at that when we connect to prove that Kerberos is being used. Other than that, we have a firewall. If you look at a firewall in 2022, the neat thing is that you have this new thingy, SMB Quick, the rules for SMB Quick. And what we're also doing is we're allowing the KDC proxy because it runs on the same server in the lab, but we block TCP 445 just to make sure that we always get 443 over UDP. Okay, so that's the server side. And of course, last but not least, we can already kick this off. We're going to have a trace running with Wireshark. Now let's go to the client. On the client, also we have, let's see, let's go here first. We have Wireshark running. Let's kick it off. There we go. What you can see here is that we have logged on to this machine, and this machine is actually not in the domain. It's a domain member. It's a domain member, but it doesn't have access to the corpnet. It only has access to the file server over UDP 443. It can talk to the KDC proxy. It can talk to the certificate revocation list to check its certificate, but that's it. So it's like it being on the internet. And as you can see, I've logged in, and I already see here that the KDC proxy is kicking in, because instead of the KDC calls showing me domain controller, it says, hey, I'm using a KDC proxy, and this is the one I'm using. So that's kind of cool to see. You configure that via group policies as such, right? You can look at it over here. But you can also configure this in the registry just in case you have some users that, let's say, don't get the GPO policies pushed anymore because they've been working at home for the last year due to the Corona crisis. So that also happens. So let's close all this. You've seen this. What we are going to do is we are going to try and access the file shares, right? So let's click a bit here and let's try to open a file. There we go. So now for the KDC proxy to kick in, the normal authentication has to fail first. So that takes a little while. So we need to have a bit of patience. Let's see what we can see. But in the trace here, you can already see that there is a lot of quick traffic going on between my server and my client. And you can see the same thing on this side. It's just trying to connect at the moment. And let's see where we are getting with this. Anytime now, if the demo gods are with us.
Did you make the requisite demo god sacrifices this morning?
Oh yes, absolutely. As always. I wouldn't miss it. Okay, there we are. So we've opened my super secret sale predictions document. And once you get it running, it's quite easy. So you can open files, you can edit them, save them, zip them, create folders. You can do everything you want. SMB over quick, over the internet, securely, without a VPN, which is quite impressive to see, actually. It's a cool thing. However, one word of warning, this is still in preview, so it's not supported in production yet. I do not know when it will be supported in production. I expect and hope at GA, but for the moment, it's not exactly production ready. But I think it's a very nice demo. It's something very cool and new to see. And I think we have use cases for this. Okay, and maybe a last thing, as part of having the KDC proxy, you can also do the password changes from the internet, which is kind of interesting with people working from home so much. So having a KDC proxy is kind of interesting. And then last but not least, REFS, Resilient File System. So Microsoft built this as a scalable and high performance file system. So what does it do? It scales, of course, and it gives you excellent performance for certain workloads. So it's not meant to replace NTFS wholesale. It's just for specific use cases like Storage Spaces Direct, Azure Stack HCI, backup and archive, where you have a lot of data, a lot of IO, and a lot of synthetic actions going on. And secondly, auto repair is available if you combine REFS with storage spaces, redundant storage spaces. That means that they can actually repair corrupt data on the fly transparently to the user or the application. So the speed for the synthetic actions comes from the block cloning capability, and detection of corruption comes from the integrity streams, which is not on by default. You have to turn it on, but that's what REFS offers you. And why are those block cloning capabilities so nice? Well, look at Hyper-V. It supports REFS. So that means if you have to create very large VHDX files, or you have to do a lot of checkpointing and merging, that all happens very fast due to the fact that the block cloning, it's not really reading and copying and writing data. It's just moving pointers to the metadata. So that speeds up things tremendously. And of course, it also saves a lot of space, because if you have to create a synthetic full backup, normally that consumes, well, the space of a full backup, but not with REFS, because it's just pointers that are being moved around, and it's a metadata operation. So that's kind of cool. Now, this is an example from a real-life environment where you see that we have about 30 terabytes of data stored on a 22 terabyte disk, but only consuming 12 terabytes. Right? How does this happen? Well, it's REFS with the synthetic actions. There's multiple synthetic full backups on these systems, but they don't consume space. That's what is happening here. It's not magic, it's REFS. Now, the integrity streams for the auto repair, it's off by default because it has some performance overhead, but for the right use case, you turn them on. And the right use case is archiving long-term storage backups. And if it's running on redundant storage spaces, a mirror, right, for example, it can actually grab the redundant copy from the storage spaces and repair that corruption on the fly, transparent to the user. And that's kind of a nice capacity to have for things that are supposed to be online, but for a very long time, because bit rot and data corruption does happen. And you don't want to have that happen silently. Hence, integrity streams can detect it for you. But if you run it on storage spaces, it can even repair it for you. That's a nice thing. Now, if you're confused about when to use NTFS versus REFS, Eric Siron from Altaro has made a very nice blog post about that, and there's a link to that over here. And I think that was it for me, and I'm gonna hand it back over to Andy.
Yeah, definitely appreciate that. Yeah, while I'm switching over and getting my slide deck back up here, one question that frequently comes up is, hey, REFS looks cool. All those features look really cool. Does Altaro leverage them? And that question comes up quite frequently. Really quick, show this window. Okay, you should see my slide deck now, Didier, right?
Yeah, we see it.
Okay, so that question comes up quite frequently. Is Altaro leveraging some of these REFS features? And the approach that we take with our backup software is we take care of all those functions in our software stack. That way, regardless of what file system you're using, you still get those features, right? So even if you're storing your backups for your Altaro backups on NTFS, we're still doing those things for you, regardless of the file system. So I just like to address that question as well, because it always comes up.
Cool.
Yeah, it's nice. We want to be inclusive of the NTFS file system, because even though it's the new technology file system, it's been out for 20 years now. Yeah, 21 years now.
Over 20 years,
yeah. Yeah. So, but anyway, it's still the default, right? So we want to make sure that we can support it and provide the same level of services for people that are storing backups on NTFS. So that kind of
makes sense.
Yep. So a couple of Q&A and wrap-up items here. So again, if you have a question you haven't asked yet, be sure to get it in that Q&A form. We're going to be looking at those in just a second. I want to run another poll really quick, though, and that is, now that you've seen the presentation, what storage technologies do you want to learn more about? And the reason that we ask this question is, if you're not familiar with us, we run a blog called the Altaro Dojo. www.altaro.com/dojo, and we cover all manner of topic there. And what we usually do with this type of information is, okay, what do you want to learn more about? If a lot of you say, hey, I want to learn more about hyperconverged solutions, we'll go out and we'll create a video or a series of videos, or we'll write some content on that particular topic to help you guys out and get you the content that you're looking for. So that's what we use this information for. I have one other quick poll and a slide or two that kind of piggybacks on top of this, but it's more just a general curiosity as well. And it kind of creates an interesting discussion when we're talking about storage technologies, right? So we'll have another poll here in just a second, but I'm gonna go ahead and close that and really quick share the results. So it looks like a lot of people are interested in cloud storage and REFS internals and usability. So REFS is a really cool file system. There's a lot in there. So I don't know, Didier, I might have to bribe you to create a video or write a blog post on some REFS internals.
I also like the fact that we've got a bit more PMEM enthusiasts here than we had in the session earlier.
Yeah, in the morning session. Yep.
41%. So
yeah, definitely.
I do have to disappoint you. I don't have stacks of PMEM lying around here on my desk, unfortunately. So
out of curiosity, when you and I started putting this together, I went out and looked at the price of Intel Optane currently, and it's It's not cheap. It's not
But
cheap.
yeah, the thing is, you have to look at it. What's my use case? And
Right.
the thing is, it's really a struggle in the market because they have that balance between being faster than NVMe, but you have to be cheaper.
Right.
And you can't have the same price as memory because you need more capacity. And if I tell you, hey, I need 4 terabytes or 10 terabytes of that, and you're going to sell it to me at level 2 or level 1 cache prices, that's not going to happen. So it's a bit of an internal struggle. We have to produce this, we have to sell this, and this has to be feasible both for the user and for the vendor. And it's a bit of a struggle. And there's a lot of things going on there, not as fast as I expected a couple of years ago. But slowly but surely, there's things happening there, and I think you will start seeing more of it in the future. Yeah.
Yeah, hopefully, because it's really cool stuff. I mean, 1.5 million IOPS. I remember when you put that slide in there the first time. I'm counting digits. I'm like, I think that's 1.5 million. Is that really? Yeah.
I remember the first time I showed those results in Redmond. It
Yep.
was like, what? I said,
It's
yes.
pretty
What?
amazing.
It's inside of VM. Yes. Is that DAX? No. It's block level. Okay. Kind of cool.
Yep.
Yeah.
Very cool indeed. All
So
right,
I'm
couple of
glancing at the questions here for a moment, or you want to first?
What's that?
I'm glancing at the questions that were asked. So
Yeah, we'll give folks a couple of minutes to get some questions in. I have like two more slides to get through here, and we'll start talking about
okay.
questions. I think we have one more poll to do really quick before then as well. So, real quick, as I mentioned earlier, Altero Software, we're now part of the Hornet Security Group. I want to let you know about a new application that Hornet Security has out. So this is actually a phone app. So you can go out to the Google Play Store today or the Apple App Store, search for Hornet Security, and you'll find this new application called Threat Monitor. What Threat Monitor is designed to do, it's designed to allow you to test the permeability of Exchange Online protection. So if you're running Exchange Online today in M365, you know that you've got Exchange Online protection doing spam filtration on all incoming email. What Threat Monitor is designed to do is it's designed to show you these are the things that Exchange Online protection let through, right? And what it does is it actually brings up those threats inside the app, gives you metrics over time, and you even have the option of deleting an offending item right from inside the application as well. And the big thing for me, putting my system engineer hat back on, there's no MX records, no MX changes need to happen for this. So I don't have to monkey with DNS, which is great. You just log into the app, you authenticate into your O365 environment, and we take it from there. So if you're interested in checking that out, you can go ahead to the URL there at the bottom of the screen. And then, a lot of people ask me like, okay, well, that's cool. Where do I go from there? If you want full end-to-end protection, including, encryption, email security, compliance, backup and recovery, we also have a product called 365 Total Protection. You can go to that URL down there for more information. One quick word on the URLs, you will be getting a copy of the slide deck, so don't feel like you have to quick jot them down. You will be getting a copy of the slide deck after the webinar. We also have a kind of a prize drawing going on for Sysadmin Day. So basically, you go to the Sysadmin Day URL, which in our follow-up email, I'm sure we'll send you a link to this. But we have a Sysadmin Day URL that you can go to. Basically, you download, you try out Threat Monitor, which I was just talking about, and you're guaranteed to get a $20 Amazon gift card. On top of that, you'll be entered into a drawing for a chance to win the grand prize. So you get an Xbox or a chair massager, and I forget what the last one is. I think it's a Visa gift card, if I remember. No, it's a wallet. I'm supposed to know these, but my memory is not that great. So, oh yeah, the URL's right there. It helps if I look at the third bullet point, right? So yeah, hornetsecurity.com/us/sysadmin-day if you are interested in checking that out. So finally, some additional resources, and I have another resources slide in another slide or two. This is just more generally, like I mentioned, the dojo earlier. If you're interested in checking out our blog, we've got altero.com/dojo. You can check out all kinds of different content there. Today, we've got backup DR, VMware, Hyper-V, and MSP related content. But we will soon be launching a Windows section that focuses on both Windows Server and Windows Client. We also have a Microsoft 365 specific section coming. On top of that, later on down the road, we're going to have an Azure section coming as well. So we used to just talk about Hyper-V, and now we're talking about all this other stuff as well. So definitely come check out our content there. We are very community oriented and are glad and happy to help. So from there, I want to run one more poll because this is just kind of an interesting question. And again, it kind of helps tie into that content angle. And that is, what is the main reason that is keeping you on old storage technologies? Is it organizational requirements? Is it budget? Is it lack of knowledge? Maybe you don't trust the newer storage technologies. Didier, you and I were talking about this one during our prep for this webinar. I think budget's going to be the winner here as well, don't you?
Yeah, budget, and second, organizational requirements. Because budget is one. I mean, the hyperconverged people like to say they're always cheaper and better than let's say the more traditional storage vendors,
Right.
but that's not always true. Let's face it, depending on your size and your needs. And then the organizational requirements. A SAN today still offers a tremendous amount of capabilities that you might want to leverage and use, so that aren't really a great fit for hyperconverged. So those two are the main reasons, I think. But the other ones, of course, lack of knowledge, because there is a learning curve, as you said, and learning how to trust newer storage technologies. I mean, let's face it, you and I work for a living, and if we advise on new storage, we kind of want to be certain that it's going to perform and be reliable, because we like our jobs and our income, right?
Yes, very much so. Very much so. All right, let's close that and see where we ended up. And it's pretty much where we ended up during the first session earlier today. And that is budget is the big concern. I think budget is actually a little bit higher in this session than it was in the first
and
one.
everybody trusts it. So that's also nice to see. Everybody.
It is. We actually had, I think, what was it, 5% in the morning session that said they don't trust newer storage
a
technology.
few percentage of people. So that's, yeah. But it's not. The big difference here is that the lack of knowledge is higher than the organizational requirements.
Right.
Which is surprising to me. Normally, I get that as a third one. Yeah.
Yep. So, all right, good info, people. Really appreciate the input. Like I said, we'll use this information to help, create some content to help you guys address this particular situation. So I'm going to go ahead and hide those results. And I think, yes, we're at our question and answer section now. So there was one question that came up earlier that I want to make sure we kind of talk about. And I think when you and I were planning for this today, I think we knew we were going to get this question at some point, and that is, will SMB over Quick be available for on-prem? And they pointed out in the previous slide, it said for Windows Server 2022 Azure Edition only, right? Can you have any thoughts on that?
Yes, but maybe not in the way you would like to, right? So it's indeed Azure Edition only, which means it's a virtual machine running in Azure or Azure Stack or Azure Stack HCI. However, your traditional Hyper-V cluster or your standalone Hyper-V host, no joy, unfortunately. So I'm always a fan of saying, provide the feedback to admins, and I hope they listen and they hear you loud and clear. Of course, it will also, I think it will have to do with the adoption. Is that a route they want to go or need to go to serve their customers? That's also something that's going to come into play. So yeah, let's see. I cannot talk for Redmond, but I hear you, and I would like to see the same. But at the moment, the biggest change is in Azure Stack HCI. So that's sort of the fast-moving part of the Hyper-V world. And then, let's say, the Windows Server itself, it gets enhancements, but it doesn't get all the latest and the greatest that Azure Stack HCI is getting. And part of that, as they explained it to us, is because, well, if you tie yourself into the standard operating system, you have to move at the speed of the standard operating system. And by taking it out into Azure Stack HCI, they allow themselves some more flexibility and agility. So,
yep, makes sense. This is another good question for you, Didier, in that, are there any competitors available today to Intel Optane that you're aware of?
Very good question. I think Intel Optane, especially if you need capacity, is the big player in town. One of the things that you should see coming, and I hope this year or at least next year, is NVDIMM NP. So you have three types of non-volatile DIMMs, the N version, is really as fast as memory, but the problem is it has the capacity of memory. So you're not going to run very far in terms of capacity, even with interleaving, right? It's just not going to happen. So then you had this F thingy, and this F thingy was basically NAND stuck on top of a memory DIMM to phase into the slot, which makes it very well. The bus is very fast, but the storage isn't that fast. So it gives you capacity, but not a great speed. And then the NVMe should be the best of both worlds, like Optane. But the specifications for that only were finished in February this year. So I hope now some people will start producing them in high enough capacities to make them competitive. And then we'll start seeing some competition. And it might also open up the game for AMD, for example, to get something in the PMEM world, because the Optane thing is tied into the Intel processor, right?
Right.
So, and then there is a lot of research going on in very interesting things, magneto RAM, nano RAM. It's amazing to read and look at, and the speeds, that's the storage class memory, right? But it is, sorry, the memory class storage,
Right.
but it can do everything, and it's the best thing since sliced bread or the invention of the wheel. But unfortunately, it is so slow to get out of the lab. But they promise you the world, and it's amazing to see what they are working on. But come on, guys, get out of the lab and get it into our hands.
Right.
At
Exactly.
a decent price point.
Right. At a decent price point. I think that's the key point, right? So I mean, really, it kind of sounds like we're in the wait and see phase, right?
Yeah.
So, well, there's one other question here I want to address before we move on to our resource slide. I know we're at the top of the hour, and that's actually got a VMware question. It's kind of an interesting question, and that is, are there any, ReFS use cases for VMware VMs? And Bing's VMware uses their own, they have their own file system that they use for their storage. I think the only play that I see here is, you could use storage spaces direct to ultimately host up like an NFS share, right? And then store your VMs on that. I think that's really the only use case that
but
I could think of.
the problem there is that S2D doesn't really support, let's say, general purpose file server
Yeah.
rules. So that's not you can do it, but wouldn't do
Yeah,
that.
it doesn't feel warm and fuzzy. Yeah.
If the real use case there might be as a backup target for archival, because what you want to
Yeah.
you dump your data, the backups on there, and if you put storage spaces on there, and that doesn't have to be S2D, it can be just redundant storage spaces, right, on standalone
Right.
member servers.
Yep.
And you can say, look, it can even be a SAN actually, as long as it's an archival workload and it's a high quality SAN on, or even a RAID controller. But with a RAID controller, you can't use S2D. So storage spaces in general. So what you want to do is redundant storage spaces with ReFS gives you that auto repair capability.
Right.
And
Exactly.
I think that's where the value is in non-Hyper-V scenarios, if that's really important to you. Of course, there are other ways to skin a cat, right? Multiple copies of backups. And I tend to be very paranoid when it comes to data protection. I have options. I can lose my primary storage. I can lose my backup. I can lose my primary backup. I have an offsite copy. I always tell the boss, I'm not the one who will clean up the mess, but I'll make sure you have clean sheets and tools to clean it up.
Yep.
Because without a backup, no matter how good you are, it's game over, right?
Yep, that's right. That's right. Yeah, so I think, short answer is there's not really a direct use case there. Like you said, Didier, the NFS angle would probably work, but yeah, not really intended, right? So
yeah.
All right, well, I want to make sure we show the resources slide here really quick, because I've mentioned it so many times throughout the webinar, right? So we got a number of resources that you can take along with here. And again, you're going to get a copy of the slide deck. So you've got some Altera resources there at the top along the lines of S2D, the hardware requirements, various technologies that are used inside of the S2D stack. I've also linked to the official depth.microsoft.com entry for S2D. And then I don't think I mentioned it in the Azure Stack HCI section, but I did mention that Microsoft has worked with third-party hardware vendors to create certified solutions to host Azure Stack HCI. If you're interested to see which vendors have a solution and what the solutions are, you can go to the Azure Stack HCI catalog, and that is hcicatalog.azurewebsites.net. Didier, he mentioned a lot about persistent memory today. He has a fantastic blog post out on his blog, workinghardinit.work, on basically persistent memory and that performance demo that you pulled the screenshots from. So fantastic resource there. He also mentioned the NTFS versus RAFS article that Eric Syren wrote, one of our longtime bloggers out in the Altera Dojo. Good article that covers a lot of the particulars in both of those file systems. We've got some general purpose Windows Server 2022 information, basically what's new in that coming operating system. And just so you know, the demo that I showed at the very beginning of the session, that was all living on a Windows Server 2022 S2D cluster. So that was all running Windows Server 2022, what you saw earlier today. On top of that, being as I was using Windows Admin Center, I wanted to post some resources on Windows Admin Center itself. So I wrote an article, it's probably a year ago now, but it still applies today. Basically, 5 ways that Windows Admin Center makes managing servers a breeze, I think is the official title, but the URL is what you see right there. And then finally, if you want to have some follow-up discussions, you want to touch base with us, you can always go to dojoforums.altera.com, or again, hit us up on our social media handles. We are always available there as well. Well, I know we're 5 minutes over. I want to be cognizant of your day. Didier, I want to say thanks for coming and sharing your knowledge. It's always good to have you, my friend. We'll be sure to have you on for a future one sometime, in the coming months.
Yeah,
and that'd be good to have you again. Yes,
always
definitely.
Thank you.
Yeah, definitely. And for those of you watching, thanks for attending. We appreciate you guys coming out, sharing your feedback, and hopefully you've gotten some good information from today's session. And we hope to see you again for a future Altera webinar sometime in the future. Thanks for watching, everyone.